Hello everyone. On October 4th, 2022, Nobel Prize in Physics has been awarded jointly to Alan Aspect, John F. Clauser, and Anton Zeilinger for experiments with entangled photons, establishing the violation of Bell's inequalities and pioneering quantum information science. Although there are several experiments that they conducted, but today I'd like to focus on first validation experiment, which is performed by Clauser with Friedman in 1972. The methods and the result of the experiment was introduced to the world by this paper, Experimental Test of Local Hidden Variable Theories. As a brief explanation of the theoretical background of this experiment, the word entanglement must be defined. In 1935, Edwin Schrödinger stated like this about entanglement, and we can comprehend that between entangled particles, what happens to one particle in an entangled pair determines what happens to the other, even if they are really too far apart to affect each other. Therefore, when we determine one state of the particle by observation, the state of entangled particle is determined simultaneously. However, when two entangled particles are far apart, it seems like the flow of information between two particles are faster than the light, which violates the theory of relativity. Regarding this, John Bell suggests the inequality that supports the hidden variable theory, which is some hidden variables that we don't know already determine the state of the particles, and our observation is just confirming the decided state. And this is CHSH inequality, which is a generalized version of Bell's inequality. Since Bell's inequality is based on the hidden variable theory, quantum mechanics become wrong if Bell's inequality is correct. Okay, then let's move on to the experiment. To verify Bell's inequality, Clauser set the equipment like this. Although it seems a little bit complicated, this can be simplified like this figure. Entangled photons emitted from the calcium atom by illumination of the light is detected after passing optical system, and this system consists of two lenses, a wavelength filter, a rotatable and removable polarizer, and single photon detector. These are the details for the emitted photons. Two photons are emitted in a j equals 0 to 1 and again to 0 atomic cascade, and absorption of 2275 angstrom photon from deuterium arc lamp, which is ultraviolet, excited calcium atoms to 3D 4p1 state from 4s2 ground state. These calcium atoms decay as a cascade to the ground state and emits two photons at 5513 angstrom and 4227 angstrom, and these are correspond to the visible light. According to the quantum mechanics, these two photons are entangled since they originated from one cycle. And these are measurements. The constant rate for two-photon detection as a function of angle between the planes of linear polarization is called r psi, and the angle psi is defined by the orientation of inserted polarizers. And it means that they differ the angle of polarizers and measure the constant rate at each angle. Moreover, R1, R2, R0 is the quantities that when the second, first, and both polarizers removed each. And in this experiment, R0 is used for normalization. So, how the hidden variable theory and quantum mechanics predicts the result? According to the hidden variable theory, the constant rate is linearly correlated with the angle because the polarization is already determined before the detection. In contrast, according to quantum mechanics, polarization is not determined before our observation, and it leads to the relation between angle and constant rate become cosine function after conducting mathematical calculation. Then, by comparing the experimental data with the expectational data of hidden variable theory and quantum mechanics, the controversy between two theories can be ended. This is the result of the experiment. This graph shows the coincidence rate with angle between the polarizers divided by the rate of both polarizers removed versus the angle. Simply R psi over R0 versus psi. The black solid line is expected data by quantum mechanics, and the black dashed line is expected data by hidden variable theory. As you can see, the experimental data is fit with the prediction by quantum mechanics, and it supports the quantum mechanics and providing the evidence against the hidden variable theory. Moreover, they verified whether the data violates the Bell's inequality or not too. For simplicity, they introduced three assumptions for hidden variable theory. First, the two photons propagate as separated localized particles. Second, a binary selection process, transmission or no transmission, occurs for each photon at each polarizer. Lastly, all photons incident on the detector have a probability of detection that is independent of whether or not the photon has passed through a polarizer. And this assumption constrains the coincidence rates by this inequality. And this inequality is not satisfied by quantum mechanical prediction by some ranges of psi, and the maximum violation is occur at 22.5 degree and 67.5 degree. This can be combined into more convenient expression like this. Using the experimental data at psi equals 22.5 degree and 67.5 degree, the delta value becomes larger than the zero, which violates the modified version of the Bell's inequality. It also proves the quantum mechanics is correct and the hidden variable theory is wrong. In conclusion, the result of this experiment conducted by Clauser and Friedman justifies the quantum mechanics and shows two particles can be entangled that the determination of the state of one particle by observation affects the other state. Furthermore, the experiments are performed more precisely and also proved the entanglement. These are references, and to get more information, please refer these papers and articles. Thank you.